Hello, Honors Algebra 2. In this video, I'm going to do a little bit on the section 4-3 in your homework, or excuse me, in your textbook, and then there's going to be homework on it. And this is something that conceptually should be reviewed from Algebra 1, but I've learned that some students need a little bit of extra review. But in this video, I'm going to do a couple problems that are a little bit more advanced. So I recommend you watch it. But if the homework for these sections is really easy for you, you don't need to watch this video. Okay, let's look briefly at what this is about. So this section is all about multiplying polynomials. To multiply two polynomials, we use the distributive property. So I'm going to explain the concept using the distributive property, and then I'm going to show you how I do it, like the shortcut, or kind of just how I organize it in practice. Okay, so we can see that we're multiplying x plus 2 times x minus 3. The distributive property is the following. The distributive property says if I have a times b plus c, where a, b, and c are any real numbers, then this is always equal to ab plus ac. Now, in this example here, the red thing is a. That's a number. I just don't know what x is. I could put in any x I want. It's an expression. So x plus 2 is a, b is x, and c is negative 3 in this case. So if I apply the distributive property, I would be multiplying x plus 2 times x minus x plus 2 times 3. Times. Well, yeah. So because I have the minus here, I put the minus there, and so this would be times 3. Okay. Simplifying this a little bit further, I would distribute the x with the normal distributive property. Yes, I know I wrote the x on the right, but that was because I was distributing the x plus 2 to x and the x plus 2 to negative 3. Now, if I continue one more step, I get x squared. I'll just switch to all black now, plus 2x, and then 3 multiplies to here with a minus, so minus 3x, and 3 multiplies to here with a minus 6. Equals x squared minus x minus 6. Okay, that is the justification for the various different versions of shortcuts that you may see. Some teachers teach FOIL meaning multiplying the first together, the outer together, the inner together, and the last. I will never mention FOIL again. Some teachers teach area models. An area model would be something like, an area model is a nice scaffold when we're learning. It would be x plus 2, x times x minus 3, and then we multiply out all the different products. X squared, x times 2 is 2x, 2 times negative 3 is negative 6, x times negative 3 is negative 3x, and if we add up all the pieces, we get x squared minus x minus 6. Nice scaffold when you're learning. We need to drop that as soon as possible because we need to be jumping straight to the answer. Okay, how do I do it? The way I do it, and the way I recommend, is to do the following. And this will generalize to multiplying trinomials together when there's more terms. I just make sure I multiply the x. I take the first term here, and I make sure I multiply the x by everything in the other factor. So let's start with that. That would be x times x, x squared, x times negative 3, negative 3x. Now I'm done with x. Now I do 2. Multiply 2 by x, and 2 times negative 3. So I get plus 2x minus 6, combine like terms, and you're done. X squared minus x minus 6. Okay, my way is a little faster. And also it generalizes, so you don't have to have any mnemonic. It generalizes to anything you multiply out. So for example, let's look at this one. I would multiply the 3 by this, the 3 by this, and the 3 by this. And then I would multiply the negative k squared by this, the negative k squared by this, and the negative k squared by this, and I know I'm done. There's 2 terms in the first, 3 terms in the second. So before I combine like terms, there's going to be 2 times 3 or 6 products that I need to write out. All right, in red, let's do the first one. 3 times 2 is 6. 3 times negative k squared is negative 3k squared. 3 times negative k to the fourth is negative 3k to the fourth. And I'm done with the green stuff. Excuse me, I'm done with the red stuff. Now we'll start the green stuff. The green stuff would be negative 2k squared. Let's see, negative 2k squared. Let's see, negative 2k squared. Now I have negative k squared times negative k squared. That's positive k to the fourth. And negative k squared times negative k to the fourth is positive k to the sixth. Combine like terms and we're done. And we'll rearrange so it's in our standard polynomial form. I'll put the largest power of k first, k to the sixth. Pause. Oh, by the way, if ever you have a long polynomial with lots of terms and you're collecting it all together, it can be helpful to kind of underline the terms that you've taken care of. I've taken care of that. Now what's the next highest power? K to the fourth. So I want to combine these two, and I would get negative 2k to the fourth. Done with those. Now what about these? Negative 5k squared. And what about this? Plus 6. And I am done. It's always good to go back and double check your signs. Negative 3k to the fourth plus, k to the sixth. Negative 3k to the fourth plus k to the fourth is negative 2k to the fourth. Negative 5k squared and 6. That's looking good. Positive, negative, 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 positive, positive. Most common mistakes are going to be minus sign mistakes. To be frank, that's what I see the most. Okay, so that's that. Now there's some special products, and this is just a result of just the definition of exponents. So when you have x plus 5 squared, this is the same as x plus 5 times x plus 5. And that is x squared plus, I'll get 5x plus another 5x plus 25. Now just notice that we got 2 of the same thing in the middle. That's a consistent thing. And also we got because these numbers are the same, we get the number squared. X squared plus 2 times 5x, which is 10x, plus 25. Not too bad. In general, what would this look like? What if I had, x plus a squared? Well, that ends up being x plus a times x plus a. And if I do this, it's x squared plus ax plus another ax plus a squared. So I get x squared plus 2ax plus a squared. And that is the same thing you see over here. I did it with x and a. The book does it with a and b, but you see you get the first thing squared plus 2 times the first times the second thing plus the second thing squared. My labeling is different, but it's the same idea. The book has examples. First squared plus 2 times the first times the second plus the second squared. And there's the same one for minus. If it's a minus b, the only difference is that will end up being a minus sign. When you do a times b, you get negative ab. When you do a times b again with the other product, you get another negative a times b, so you get negative 2ab. But negative b squared is positive b squared. So that's why the second one is positive. Okay. And so when you have a plus b times a minus b, if we were to do the distributive property the way I did before, we would get a squared minus ab, that's this one, and then this would be plus AB, and this one would be minus B squared. Now, because the signs are different, you get a minus B squared, and these two have opposite sign. So what always happens is these two cancel each other out, or they sum to 0 is a better way to say it. So then this would be A squared minus B squared, which is what the book is showing. You need to memorize these special products. So if you see a binomial that's squared in this form, you should be able to just write this out. If you see this with a minus, you should just be able to write this out. So whatever is in A, you plug it in for A. Whatever is in the place of B, you plug it in for B, and you got to do it fast. You got to know that you also need to be able to recognize if it looks like this, you can go the other direction. And if you get A squared minus B squared, you can go the other direction. Example, nx minus m squared, minus m all squared. I can see that this looks like A minus B squared. Well, what's that? We got to memorize it. So write it down. Practice writing it down. A squared minus 2AB plus B squared. Well, let's switch to black for my answer. What's A? A is nx. So it's nx squared minus 2 times the first thing. What's the first thing? Nx. Times the second thing. What's the second thing? M. Plus B squared. B is here. B is M. Oops, not B. B is M. Okay, now we're just going to simplify things, and I'll do that in a moment. But please notice, this minus is not part of B. B is whatever number is written here. This minus is handled by memorizing the formula with this minus here. In this example, A is nx, B is m. So we just plug it into those places and know that a minus goes here, and that's the shortcut to work it out fast. N squared x squared minus 2 nx, minus 2 nmx plus m squared. I'll assume in context that x is probably the variable, and n and m are likely fixed constants or fixed real numbers. They're not variables. We just don't know what they are. They could be any real number, but x is actually our input variable to the expression. Some other quick examples. Now here's where you could pause the video and try this. Be a good practice problem. This is in the packet I already gave you, and give it a try. Or if you didn't get the packet or don't have it, you can just try it on paper right now. Okay. This is this is the situation that's of the form A minus B times A plus B is equal to A squared minus B squared. And A is P squared and B is 2Q squared. So this is going to be P squared squared, because A is P squared, B is 2Q squared. So P squared squared is A squared minus B squared. But what's B? B is 2Q squared. P to the fourth minus 4Q to the fourth. All right. That's it. Here's another one you could try. This is an important project we're going to need to know once you see the end. Let's multiply this out. Oh, actually, no, this is, I changed the sign on this. This is not one of the special products. But anyway, let's just do it. So since I'm multiplying a binomial times a trinomial, there's no shortcut we know yet. So you just brute force it out. You multiply this by everything. A times A squared is A cubed. A times AB is A squared B. a times b squared is ab squared. Now in green, for the sake of keeping things organized, I will multiply out. Oops, I pointed all those to b, but I meant to, or excuse me, I pointed them all to a, but I want to distribute the b to everything. So b times a squared, ba squared. Let me change that to green. B times ab, ab squared. B times b squared, b cubed. Okay, just double check. I think I've done everything correct. I'm not going from notes here. I'm just doing it in front of you on the video. That's okay. Let's combine everything. I've got a cubed plus, well, I have a squared b and a squared b. So I've taken care of that. Now these are like terms, so I get 2a squared b. And then what have I got here? I got ab squared and another ab squared plus 2ab squared plus b cubed. Okay, nice.